Astronomers have found a monster quasar in the early universe. An international team of astronomers has discovered the second most distant quasar ever found. It has been named Poniua'ena and designated J100 758.264 plus 211 529.207, or simply J1007 plus 2115. The object is around 13.1 billion light years away and contains a huge black hole with the mass equivalent to about 1.5 billion suns, but twice as massive as that in the most distant known quasar, ULAS J134 208.10 plus 09 28 38.61. The existence of such a massive black hole just 700 million years after the Big Bang significantly challenges models of the growth of the earliest supermassive black holes. Poniua'ena is the most distant object known in the universe, hosting a black hole exceeding 1 billion solar masses. For a black hole of this size to form this early in the universe, it would need to start as 10,000 solar mass seed black hole about 100 million years after the Big Bang, rather than growing from a much smaller black hole formed by the collapse of a single star. Current theory suggests that at the beginning of the universe, following the Big Bang, atoms were too distant from one another to interact and form stars and galaxies. The birth of stars and galaxies as we know them happened around the epoch of reionization, beginning around 400 million years after the Big Bang. The discovery of quasars like Poniua'ena deep into the reionization epoch is a big step towards understanding this process of reionization and the formation of early supermassive black holes and massive galaxies. How can the universe produce such a massive black hole so early in its history? This discovery presents the biggest challenge yet for the theory of black hole formation and growth in the early universe. Poniua'ena acts like a cosmic lighthouse. As its light travels the long journey towards Earth, its spectrum is altered by diffuse gas in the intergalactic medium, which allowed us to pinpoint when the epoch of reionization occurred. This discovery of the most massive quasar known in the early universe contains a massive black hole with a mass that is equivalent to 1.5 billion suns, formally designated as J1007 plus 2115. The newly discovered quasar is one of only two known from the same cosmological period. Quasars are the most energetic objects in the universe, and since their discovery, astronomers have been keen to determine when they first appeared in our cosmic history. In honor of its discovery via telescopes and Mauna Kea, a mountain revered in the Hawaiian culture, the quasar was given the Hawaiian name Poniua'ena, meaning unseen spinning source of creation, surrounded with brilliance. It is the first quasar to receive an indigenous name, which was created by 30 Hawaiian immersion school teachers during a workshop led by the Ewa E Inoa Group, a Hawaiian naming program led by the Imola Astronomy Center of Hawaii. According to current theory, quasars are powered by supermassive black holes. As the black holes gobble up surrounding matter such as dust, gas, or even entire stars, they emit tremendous amounts of energy, which results in luminosities known to outshine entire galaxies. The supermassive black hole powering Poniua'ena makes this quasar the most distant and therefore the earliest object known in the universe to host a black hole exceeding 1 billion solar masses. According to a new study documenting the quasar's discovery, the light from Poniua'ena took 13.02 billion years to reach Earth, starting its journey just 700 million years after the Big Bang. It is the earliest monster of this kind that we know of. The question of how such a massive black hole could materialize when the universe was still in its infancy has vexed astronomers and cosmologists for a long period of time. The time was too short for it to grow from a small black hole to the enormous size that we see today. This discovery presents the biggest challenge yet for the theory of black hole formation and growth in the early universe. The notion that a black hole of Poniua'ena's proportions could have evolved from a much smaller black hole formed from the collapse of a single star in such a short time period since the Big Bang is next to impossible. Instead, the study's authors suggest that the quasar would have had to start out as a seed black hole already containing the equivalent mass of 10,000 suns as early as 100 million years after the Big Bang. Poniua'ena was discovered through a systematic search for the most distant quasars. It began with the research team combing through large area surveys such as the Decals Imaging Survey, which uses the dark energy camera on the Victor M. Blanco 4-meter telescope located at the Cerro Tololo Inter-American Observatory in Chile, and the UHS Imaging Survey, which uses the wide field camera on the UK Infrared Telescope located at Mauna Kea. The team uncovered a possible quasar in the data, and in 2019 observed it with telescopes including the Gemini North Telescope and the W.M. Keck Observatory, both on Mauna Kea. The Magellan Telescope at the Las Campanas Observatory in Chile confirmed the existence of Poniua'ena. Observations with Gemini were critical for obtaining the high-quality near-infrared spectra that provided us with the measurement of the black hole's astounding mass. The discovery of a quasar from the dawn of the cosmos provides researchers with a rare glimpse into time when the universe was still young and very different from what we see today. Current theory suggests that at the beginning of the universe following the Big Bang, atoms were too distant from one another to interact and form stars and galaxies. The birth of stars and galaxies as we know them happened during the epoch of re-ionization, which is about 400 million years after the Big Bang. In the aftermath of the Big Bang, the universe was very cold, because there were no stars yet, and therefore no light. It took about 300 to 400 million years for the first stars and galaxies to appear, and they began eating up the universe. Under the influence of heating, hydrogen molecules were stripped of electrons in a process known as ionization. This process lasted only a few 100 million years, a blink in the life of the universe. And this is the subject of ongoing research. The discovery of quasars, like Poniua'ena, deep into the reionization epoch, is a big step towards understanding the process of reionization and the formation of early supermassive black holes and massive galaxies. Poniua'ena has placed new and important constraints on the evolution of the matter between galaxies, known as the intergalactic medium, during the re-ionization epoch. This quasar looks like it was detected right at the midpoint of that period, and the fact that we can observe these objects helps us to refine what happened during those early years of the universe. In 2008, the survey team announced the discovery of the most distant quasar found to date. It was designated as J1342 plus 0928. That object is 2 million years older than Poniua'ena, a rather insignificant difference by cosmic standards. Who was involved in both discoveries, Fan has said that these make the International Gemini Observatory and Cerro Tololo Inter-American Observatory both programs of the National Science Foundation's National Optical Infrared Astronomy Research Laboratory. The difference of 2 million light years out of 13 billion makes that pretty close to tie. Been the review of astronomers' discovery of a monster quasar that was found in the early years of our universe, and it poses a lot of challenges for cosmologists and astronomers alike. Now remember to like, comment, share, and subscribe. Stay tuned to the Learning Academy for further information and details on all space and astronomy related matters. Subscribe if you have not already done so. Like, comment, share, and subscribe. We crave your feedback. Let us know what you think about this monster quasar that was discovered in the early infancy years of our universe. It is 2 million years younger than the first discovery of that monster quasar. Thanks for watching, and remember to like, comment, share, and subscribe.